Hello everyone, today I want to talk about the interpolation search. My name is Rong and this is my email address. So I'm talking about the presentation 4 and the topic 4. Here, this is what I want to talk about the interpolation search, the algorithm running time, and how this algorithm works, and code for this algorithm. Here, this is the running time for this searching. The average runtime is big O log and log n. The worst case is O log n. And as we know, this search is similar to the binary search, and the binary search is big O log n. So why this one is maybe better than the binary search, because when we search something, we don't want to just divide it by two parts or just get a median from the half and high minus low. So we have this one to find the what we want more exactly. And here, this is an example. This example can explain what did I say. So here we have array for 0, 1, 2, 2000, 2001, and blah, 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 through to 100,000. And the mid to count the mid of this array, we have this formula. And this formula is totally different with the binary one. The binary one, we only have the high, minus, low, and half. So we find the mid of the whole array. For this array, this example, we want to find 5,555. So the mid of this one is 0 plus the number minus the low key, and divided the highest number in this array minus the lowest number in this array, and also we have 12 elements in this array, so we get 0.6666 in this position. So the position we have is 0. So the mid is 0. So we can't search this array from the index 0. And it will search nighttime because we search them what is the mid, and second we search this one. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 time to search the whole array to find what we have. You can see this example is not a good example to let you guys know why this one is better than the binary, but this one is a good example to let you guys know why this the interpolation or search is not better than binary sometimes, because we have the unbalanced array of this. We have 0, 1, 2, and jump to 2000. So this array is not balanced. So if we want to find something bigger than 2000 or just near the biggest number in this array, we should find more specific number on this. Like if we want to find, we still want to find 5,555, we should better find this array from 2004. And in this array, the 2004 is near the binary middle, the binary search middle. So that is better. We use binary search to find the number in this array. But if this array have 0, 1, 2, 4, 5, 6 through to the 12, that we should use, and we want to find something like 2 or 12, we should use the interpolation search, because in that case we have a balanced array, and this array is totally perfect to search for a specific number by using interpolation array. And here, this is the code for this interpolation array in C programming language. First, we have a function. We want the argument about number. This is an int array, and this is the value we want to find. And first, we initial the low and upper to value to get the highest value, to get the lowest value and the highest value. And well, if the low less and equal than upper, we do these things. First, this is to use the formula to count the middle, and then we get middle. If the middle equal to lower or middle bigger than upper, we can find the middle in this array. So we break this through and return -1. And if the find is less than number, is the number made in this array, we know that the numbers will exist in the left side of this middle. And the same, this if the find bigger than the number made, so we know what we find it will exist in the other side of the made. And we have the upper equal to made -1 and lower mister. So we keep update this through this, and we can then we will find what we find and find the index. Then we return the mid, because the mid is not it's not fixed. It's always -1 or +1. So the mid in this logic is it always changes. It's changed to from left side to find or the other side to find. So then we keep through. We will have the lower after. We will have the mid as equal to mid. So the find equal to mid, that's what we want, and we return the mid. So this is the algorithm about the code. Okay, thank you for watching. And this is